Hi, today we're looking at Functional Skills Maths Level 1 with the AQA exam board. This is the January 2020 paper and we're going to start with the non-calculator section. Question 1. Circle the smallest number. Okay, so what we're going to have a look at is the whole number to start with. They all start with a 7. Okay, so then we look at the next digit along. So we've got a 0. We've got a 1, we've got a 0, we've got another 0. So it can't be this one because 0 is smaller than 1. But because these all have a 0 as the next digit, we move along to the next digit, so the second decimal place here. We've got a 9, we've got a 3, and we've got a 4. Well, 3 is smaller than 9, and it's also smaller than 4, so it's going to be that one. Okay, we don't need to look at the other digits afterwards because they're all going to be even smaller. So this is we're starting from left to right and moving along that way. Question 2. Write in words, and we've got 1, 0, 3, 2, 4. So the first thing I'm going to do is put my comma in, so we count back 1, 2, 3, put that in there. Now I think this helps to make it a lot easier. So now we've got 10. So between the commas we just read the number we've got. So we've got 10, and the comma here is indicating that it's thousands, so 10,000. Then we look at the number to the other side of the comma, and we've got 324. So 10,000, 324. Just like that. Okay. Question 3. Work out the range of these numbers. Well, the range is the biggest number minus the smallest number. And they put these in an increasing order as well to make it easier. So we can see the biggest number is 9. Smallest number is 2. So we want 9 minus 2. So if you count back 2 from 9, you get an answer of 7. And on to question 4 down here. Work out 718.6 divided by 100. Okay, well, if we're dividing by 10 or 100 or 1,000, all we need to do is to move the decimal place. Now we're dividing, so that's going to make the number smaller. So we need to move the decimal point. We're going to move the decimal point to the left to make this number smaller. We've got 2 zeros, so we're going to move the decimal point 2 times. Move it twice. Okay, so that means it's now going to look like 7.186. Okay, and on to question 5. By rounding each number, estimate the answer to 9.8 times 4.1. You must show you're working. So if we're estimating, that means we're going to be doing some rounding. Okay, so what we can do is we can say, well, 9.8. Well, what's it close to? Well, it's very close to 10. Okay, we don't need to look and say, oh, do we round up or down? We just sort of, almost bit of sort of common sense, just have a look at it and say, what number's it near? Okay, and similarly with 4.1, we can say, well, 4.1 is just over 4. Okay, so if we're doing the estimate, now we can just say, instead of 9.8 times 4.1, we can say 10 times 4, which hopefully you all know is 40. Question 6. Here is an L shape. Work out the perimeter of the L shape. Well, the perimeter is the distance all the way around the shape. So we're just going to add up all of these lengths because we've got them all marked out. So I'm going to show that I'm starting here so I don't miss anything. So we've got 10, write it down here, plus 12, plus 7, and then plus 8 up here, and plus 3 along here, and then finally plus 4 to get back to where we started. Okay, I've written them horizontally. We could have written them down as a as a column to make it easy to add up. But what I'm going to do now is I'm going to match these together for the adding. I'm going to say, well, 12 and 8, that's going to give me 20. And 7 and 3 is going to give me 10. So now we've got 10 plus 20 plus 10, and all that's left is a 4 at the end. So 10, 20, 30, 40, 4. Okay. Question 7. Birthday party. Carly is shopping for things for her son's birthday party. 7a. Carly is buying paper plates and paper cups. Plates cost £1.50 for a pack of 8, and cups cost £1.20 for a pack of 6. Carly wants 40 plates and 24 cups. Carly says the total cost will be less than £12. Is she correct? We've got 5 marks for this. So what we're going to do is we're going to work out what the total cost is and then compare it to the £12. So if we want 40 plates, well, we're going to say, well, if I want 40 plates, they're coming in packs of 8. So how many packs do I need? So we're saying 40 divided by 8. Okay. Now, if you don't know your divisions easily, you can do multiplications instead. So you can say, well, we've got 8, 16, 24, 32, 40. So that's 5 times. Okay, so we're going to need 5 packs. We might as well work out the same for the cups while we're at it. So with cups, they come in packs of 6, and we want 24 cups. So we want 24 divided by 6. So we've got 6, 12, 18, 24. So that's 4 packs. And I'll put that's for plates, and that's for cups. Okay, so 5 packs of plates, and each pack costs £1.50. So we've got £1.50 times 5. Okay, well, we can say 5 times 0 is 0. 5 times 5 is 25. So 5 carry the 2. Bring the decimal point down. 1 times 5 is 5. Plus the 2 is 7. So we've got £7.50. Now, I left the decimal point in there. What you can do is take the decimal point out, so ignore the decimal point, do the multiplication, and then because you've got 2 decimal places, you just need to make sure you put the decimal point in 2 places, which would still give us the same answer. So this is the cost for the plates. For the cups, we've got £1.20 for the cups, and we said we need 4 packs. So 4 times 0 is 0, 4 times 2 is 8, put a decimal point, and 4 times 1, or 1 times 4, is 4. Okay. So for the total cost, we want £7.50 plus £4.80. 0 plus 0 is 0, 5 plus 8 is 13, put our decimal point, 7 plus 4 is 11, plus 1 gives us 12. Well, that is more than £12, so no. She is incorrect, because she said it would be less than 12, but it's more. Seven B. Carly will give each child a bag of sweets. She buys a 1 kilogram box of sweets. She puts 50 grams of sweets into each bag. How many bags can she fill from the 1 kilogram box of sweets? Okay, well, I know that 1 kilogram is equal to 1,000 grams. So we want to know how many 50 grams will go into 1,000. Or in other words, 1,000 divided by 50. Well, because we've got zeros on both of them, we can cancel a 0. So we're saying this is the same as 100 divided by 5. So let's do this with the bus stop method. 5 on the outside, 100 on the inside. How many times does 5 go into 1? Well, 5 can't go into 1. So we look at how many times 5 goes into 10. So it's 5, 10. So that's twice. And again, how many times does 5 go into 0? It doesn't. So it's a 0. So make sure we need to put that 0 on for the second one, so we end up with an answer of 20 bags. (7C). Carly makes a drink by mixing orange juice and water in the ratio 1:6. She uses 2 litres of orange juice. How many litres of the drink does she make? So let's do a nice simple ratio table. So we've got orange juice and water. So we've got OJ, water, and we're going to have a total column. And the ratio is 1 orange juice to 6 water. And if that's all we had, well, 1 plus 6 would give us a total of 7. Now they're saying she uses 2 litres of orange juice. So we haven't got 1, we've actually got 2. So hopefully you can see that from this row to this row, we're doubling it or multiplying by 2 to get from 1 to 2. So we need to do exactly the same with the water and the total. So 6 times 2 gives us 12, and 7 times 2, because this needs to be the same for all of them, gives us 14. How many litres of the drink does she make? So it is our 14 litres. We didn't have to work out this 12 here, but the reason I do that is because it's good as a check, because we can say 2 plus 12 equals 14, which is great. We want that to all add up. Okay. 7D. Carly wants to hire a hall for the party. The charge for hiring the hall is worked out using this formula. So the charge is equal to £50 plus 30 times the number of hours it's hired for. Okay. Carly is charged £140 for hiring the hall. For how many hours does she hire the hall? So let's put our numbers into this. So the charge, well, we're told that the charge is 140. And we know that that's equal to 50 plus 30 times, and the number of hours, I'm going to put an H. Okay, we don't know what it is, so we'll just put like a placeholder there. Okay. So what I've done is I've just got rid of some of the words. So hopefully it's now a bit easier to deal with. Now, using our BIDMAS rules, we know that the multiplier would be done first. So what that means is that this bit is all sort of like kept together. Now we're trying to work this H out, so what we actually want to do is to get rid of this 50. So what we're saying is, if the total cost is £140, sorry, the total cost of £140 is 50 plus this thing, well, if we take 50 away, so 140 minus a 50, then all that's going to be left is this thing here, which happens to be 30 times H. Okay, so 140 minus 50, 0 minus 0, 0, and 14 minus 5 is 9. So this side is equal to 90, and that's 30 times H. So if we want to know what 1H is, we're saying, well, what number multiplied by 30 will give me 90? Or in other words, we're saying that H is equal to 90, and I'm going to do it as a fraction, 90 divided by 30. And the reason I've written it as a fraction, I could write it as 90 divided by 30, but I think it's easy to see here that now we can cancel the zeros. So actually we're just left with 9 divided by 3, which I'm sure you'll know is 3. And that's the end of the non-calculated section. And now for the calculated section. Question 1. Which of the following is a net of a cube? Right, well, let's just draw a cube. To cube, looks like that. So think of it as a dice. And if you remember, with a dice, you've got 6 sides on it. Okay, so let's see how many sides we've got here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so that's not helped, but it's worth looking at that, okay? Then we can say, well, to make this cube, we've got sort of 4 going round in the line, if you like, and then we've got 1 on top and 1 at the bottom. So we're looking for a strip of 4, and it's not the only way to do it, but it's a nice way to start. So looking at D here, we've got a strip of 4, 1 that could fold up for the bottom and 1 that could fold down for the top. Or if you think of this as going around the middle, this would then be on the left side and this on the right side. So that's going to be our answer. If you look at some of the others, for example, A, we've still got 4 in a line, which is great, but then we'd have like our top and bottom piece both on the same side. So that's not going to work. With B, we've got 5 in a line, so that's not going to work because that's not going to give us our nice 4 going around. We're going to have an extra 1, so we know it can't be those 2. And C, well, we've got 3 in one direction and then 3 in another, which again isn't going to work with our cube because we want the 4 going one way and then just our 2 flaps, top and bottom. Question 2, 52 squared. Well, 52 squared means 52 times 52. And before you start working that out, remind yourself this is the calculator section, so we can just type it in. Okay. Question 3. Here is a regular hexagon. How many lines of symmetry does the hexagon have? Circle your answer. All right, so hexagon, we know is a 6-sided shape. A regular hexagon, well, that means that all of the sides, and therefore all of the angles, must be the same. Okay, so that's going to help us with our lines of symmetry. Because if it was an irregular hexagon, then we wouldn't necessarily know. We'd have to measure everything out and be very precise. But if we know that these are all the same, well, then I can say I want a line of symmetry, so I can cut the shape in half that way. I can also cut this shape in half that way. And in fact, if we turn the shape, we've got our hexagon again. So again, we can cut it in half that way. And we can cut the shape in half horizontally as well. And then for the other lines of symmetry, again, if we turn it this way, we can see, oh, well, I can cut the shape top to bottom again. And I can cut the shape from left to right. Okay. Now, we did that using 6 lines. And in fact, if it's a regular shape, then the number of lines of symmetry will be equal to the number of sides we've got on the shape. So it's going to be 6. Question 4. A fair, ordinary 6-sided dice is rolled. Write down the probability that it lands on a number greater than 4. Give your answer as a fraction. Well, a 6-sided dice, so the total number of values or answers we could get when we roll the dice is 6. We want a number greater than 4. So in other words, it can be a 5 or a 6. So we've got 2 possible outcomes. We can leave it like that, or we could simplify it and say 2 goes into both of these numbers, 2 goes into 2 once, 2 goes into 6 3 times. But they haven't said simplify it, so this would be absolutely fine if you left it like that. Question 5. Measure the size of angle X. So you're going to need your protractor. Okay, this is the angle we're measuring. So we want the crosshairs of the protractor here to be on this corner here. And we want one of these lines at the bottom to line up with one of these lines. So I'm going to show you 2 ways of doing it. So we can either do it here, line this one up with the right. If we're doing it from this way, because this is the angle, so we want the angle inside, we're saying, well, this is starting at 0. So we're going to start at 0, 10, 20, 30, 40, and go all the way around until we find where the line is coming up. Now we're just going to move it slightly. And in fact, the line is coming up right here, which is 130 degrees. Okay. Now, we could measure it starting from this line instead. So again, we get the crosshairs there, line it up on the left. Now, if we're going to start on this side, we need to start from 0 here. So we're looking at the numbers on the top this time. So 0, 10, 20, 30, all the way around till we get to the horizontal, which is still 130 degrees. So it doesn't matter which way you do it, your answer should be the same. Okay. And if you happened to use the other number, so for example, say we said, oh, it must be 50 degrees. Well, then you can do your check. So we know that this is more than a right angle, so the answer has to be more than 90. Question 6. Work out the number of minutes in 7 days. Right, well, let's start off small. So we've got 60 minutes in 1 hour. Then we've got 24 hours in 1 day. And then we've got 7 days in 7 days. I know that seems obvious, but the reason for doing that is we can see that what we're trying to do is to multiply these numbers together. So if we do 60 times 24, that tells us we've got 1,440 minutes in 1 day. And if we multiply that by the 7, which we've got there, that's the number of minutes in 7 days. So 10,080 minutes. Question 7. Which of these write these fractions in order, starting with the smallest. So we've got different denominators here, so we could find a common denominator. But again, remember, you've got your calculator. So we can just say 7/10 is 7 divided by 10. So 0.7. 3/4 is 3 divided by 4, or 3/4, which is 0.75. And 2 divided by 3 is 0.66. Keep going. So the smallest number, well, we've got a 0.7, another 0.7, and a 0.6. So it doesn't matter what numbers come after it. This is going to be the smallest. So 2/3. 0.7 or 0.75. Well, this has got more. So this is going to be the next one. The 7/10. And last would be the 3/4. Question 8. Here are 7 numbers. Here I've got them all written out. Work out the mean. Here, well, the mean is the total divided by how many? So we want to add them all up. So we've got 4 plus 12 plus 10 plus 13 plus 4 plus 6 plus 14. So we've got 63. And how many? 1, 2, 3, 4, 5, 6, 7. So 63 divided by 7 gives us 9, which we can write down here. Question 9. Hotel. Vicky and Zach work part-time in a hotel. Vicky works on the reception desk. Her normal rate of pay is £9.65 per hour. She is paid double for working on a bank holiday. 1 week she works for 30 hours in total. 26 of these hours are at her normal rate of pay. The other hours are on a bank holiday. Work out her total pay for the week. Right, 26 hours at £9.65. Yeah. Which gives us £250.9. Well, because it's money, we have to put the 0 on to make it 90p. Right, now the other hours. Well, how many others are there? Well, there's 30 in total. 26 are at this rate. So 30 minus 26 will give us however many is left over, which gives us 4. And that is at twice her normal rate. She's paid double. Okay, so it's going to be 4 times £9.65, but because it's double, we can multiply that by 2. It doesn't matter which order you do the multiplications. So 4 times £9.65 times 2. So we've got £77.20. So the total is going to be these two added together. So £77.20 plus £250.90. And that gives us 328.1. So again, because it's money, it's going to be 10p. (9b). Zach is a porter in the hotel. He takes the guests' luggage to their rooms. He is paid £8.10p per hour. Here are the hours he worked 1 week. So on Monday, he worked from 5 p.m. to 9 p.m. Thursday, 3 p.m. to 6 p.m. And on Saturday, he worked 10 a.m. to 2 p.m. Was he paid more than £90 for the week? You must show your working. Well, we want to know how many hours he worked in total. So on Monday, 5 to 9, so that would be 1 hour to 6 o'clock, 7, 8, 9. So that's 4 hours. From 3 to 6. We could do 9 minus 5 to give us 4, but I'm going to count up because I think it's easier. So from 3, it's 4, 5, 6. So that's 3 hours. And from 10 a.m. to 2 p.m, we'll go 11 a.m, 12 p.m, 1 p.m, 2 p.m. So it's another 4 hours. So how many hours in total? Well, 4 plus 3 plus 4 gives us 11 hours. So we've got 11 hours at £8.10p. Which gives us £89.10p. Remembering again, because we need to put the 0 on, because it's money, we've got to have 2 decimal places. And that's less than £90. So was he paid more than £90? No. (9c). Zach gets £23.80 in tips from guests. He keeps 85% of this money. He gives the rest to Vicky. How much money does he give to Vicky? Right, well, let's work out what 85% of this is. So it's going to be 85 out of 100 times £23. £23.80. So 85 divided by 100. Now, if you know your decimals, you can go straight to 0.85. And then if we multiply that by £23.80, we get £20.23. So that's how much he keeps. What Vicky keeps is the difference. So it's the £23.80 minus £20.23. Which is £3.57. (9d). Zach wants to save £185 to buy a keyboard. He saves £35 each week. How many weeks does it take him to save enough money to buy the keyboard? We want to know how many 35s do we need to get up to 185? Or in other words, 185 divided by 35. Which is 5.2857, blah, blah, blah. Now, I say blah, 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 because we don't really care about that. It's how many weeks. So we want full weeks. Well, if we only do 5 weeks, well, 5 weeks isn't going to be enough, because 5 times 35 only gets £175. So we're going to have to go up to the next whole number, which is 6. So the answer is 6 weeks. Gardener. Beth is a gardener. Here is a sketch of a rectangular garden she is designing. So we've got our rectangle here, 50 metres long and 7.2 metres wide or up. Beth wants to cover 1/3 of the area of the garden with lawn turf. Lawn turf costs £2.75p per square metre. It can be cut to fit any area. Work out the cost of the lawn turf she will need. Okay, right. She wants to cover 1/3. So I'm going to draw it on. Doesn't have to be exact. I'll say that's about 1/3. So this is going to be the lawn. Right, well, we want to work out the area first, so we can then work out the cost. Well, if it's 1/3, well, actually, let's start off. For the area of a rectangle, we want the length times the width. But for the lawn, we've got this distance, which is 7.2 metres, but we haven't got this one here. But we know that it is 1/3 of the area of the garden. So it's going to be 1/3 of 15. Well, in other words, 15 divided by 3, which is 5. So the area is going to be 7.2 times 5, or 5 times 7.2, which gives us 36 metres squared. So we've got 36 metres squared, and lawn turf costs £2.75 per square metre. So if we multiply these together, we get £99. What you could do instead is you could work out the total area of this. So you could have said 15 times 7.2 to give 108. Then multiply it by 2.75, which will give you the cost for the whole garden, and then say, well, I only want 1/3 of that. Divide it by 3, still get 99. So there's more than one way to do this question. Part B. There will be a pond for fish in the garden. The pond will be a cuboid of length 2.5 metres and width 1.8 metres. The pond will be filled with water to a depth of 1.2 metres, shown there. 1 cubic metre equals 1,000 litres. Each fish needs 360 litres of water. Work out the maximum number of fish that can be kept in the pond. Alright, so what we need to do is we need to work out how many litres will fit in this pond. And then we can work out how many fish will go in that space. Okay, but before we can work out litres, we need to work out the measurement in metres, because we're told that 1 cubic metre is 1,000 litres. So we want, let's call it the volume. So the volume is the length times the width times the height, which is, our length is 2.5, our width is 1.8, and our height is 1.2. So 2.5 times 1.8 times 1.2 gives us 5.4 metres cubed, or cubic metres, if I want to say it like that. Now, we now want to turn that into litres. So 1 cubic metre is 1,000 litres, so we need to multiply that by 1,000. So 5.4 times 1,000, and we get 5,400 litres. If each fish needs 360 litres, we want to know how many 360s will fit into this pond, which is 5,400 litres. So that's the same as saying 5,400 divided by 360, which gives us a nice round 15. That's the number of fish. C. Beth wants to buy some rose bushes for a flower bed in the garden. She sees this advert. Rose bushes, £13.50 each. Buy one, get one half price. How much will Beth pay for 6 rose bushes using this offer? Right. So 6. Well, she could buy one. She has to pay full price. The second one, she gets a half price. The third bush should have to pay at full price again. The fourth one should get another one at half price. The fifth one should have to pay full price. And the sixth one, again, should get half price. So we've got 1, 2, 3. Half and half makes 4 and a half. Or 4.5. So that's how many bushes she's actually got to pay for. So 4.5 times £13.50 gives us £60.75. Now you might prefer to say, well, I want to work out what half price of a bush is and then add them up, which is fine. So you could say £13.50 divided by 2, which is the same as times a half. So the half price is £6.75. So then you can say, well, I've got 3 at £13.50 and 3 at half price. So let's do this. So 3 times £13.50 would be £40.50. 3 at £6.75 would be £20.25. And if we add those together, we get the same answer of £6.75. So that's just an alternative way of doing it. Question 11. Concert. Anya is organising an outdoor concert. Anya is planning where to put refreshment stalls. There will be 3 rectangular food stalls, each measuring 6 metres by 2 metres. 2 square food stalls, each measuring 4 metres by 4 metres. And 1 rectangular drink stall measuring 6 metres by 3 metres. There must be at least 2 metres of space between stalls. The centimetre grid represents a scale drawing of the area she can use. And that's down here. On the grid, get it on there, yeah. On the grid, 1 centimetre represents 2 metres. Draw a possible plan for the stalls on the centimetre grid. Okay, and we've got the scale here, the 1 centimetre, so one of these, that's 1 centimetre, represents 2 metres. Okay, so let's go back and look at what we've got to put on the grid. So 3 rectangular food stalls, so let's just do a sketch of a rectangle. 6 metres by 2 metres. Well, that's great with the metres. What we want to do is we want to convert that into centimetres so we know how many squares we're going to need on our grid. Well, if 1 centimetre represents 2 metres, so actually we can say 2 metres, well, that's 1 centimetre, that's what they're telling us. So 6 metres, well, that's 2, 4, 6. So that's going to be represented by 3 centimetres. Now we've got some square food stalls. So There's our square. So each side is 4 meters. So again, if we try and convert that into, well, if that's 4 meters, how many centimeters it'll be? Well, 4 meters is 2 lots of 2 meters. So it's going to be represented by 2 centimeters. And one rectangular drink stall measuring 6 meters by 3 meters. So we're going to have another rectangle like that. 6 meters, which we've already seen, is represented by 3 meters. And this side is going to be 3 meters. Well, if 1 centimeter represents 2 meters, well, if you think, well, an extra 1 meter is going to be, 1 meter is half of 2, so it's going to be half of this. So 3 meters is going to be 1.5 centimeters. Yeah, so to get from 2 to 3, we're going up by 1.5. So we've got 1 and half of 1, which is a half. So we know what our tables are going to look like. Now we need to fit them on the grid. So we've got 3 of the food stalls, 2 of the three rectangular food stalls, 2 square food stalls, and 1 rectangular drinks table. Well, the rectangular drinks table is the biggest table. So I'm going to put that on my grid first. So we've got 6 meters, or well, let's look at it in terms of centimeters, because that's how many squares we're going to need. So 3 centimeters by 1.5 centimeter. So we can just put that in the first corner, top left. Okay, so 6 meters, well, we've got 3 centimeters. So 1, 2, 3. That's to here. And it needs to be 1.5 centimeters, so 1.5. So we're going to have something that looks like that. Okay. It does say there must be at least 2 meters of space between stalls. Well, 2 meters, we know that that's going to be 1 centimeter. Okay, so this is our rectangular drinks stall. Okay, so we've got that in the corner. It doesn't say that we need any space between the edge of the tables, but we do need the space between the tables. Right, so what can we go next? Now let's go for the next biggest table. So I'll probably go for these rectangular ones. So we've got 3 centimeters by 1 centimeter. So we need 1 centimeter gap in between. So maybe let's do a table here. 1 by 3. So this is going to be a food stall. And it's clearly a rectangular one. Or maybe we can fit another food stall in this corner. So we need another 3 by 1 rectangle. So this could be a food stall. And we need 3 of these ones. So maybe 1 meter down from this. We can fit that one in here. Yeah, so we've got 1 rectangular drink stall, which is 3 centimeters by 1.5 centimeters, done. Then we want 3 rectangular food stalls, which are 3 centimeters by 1 centimeter. 1, 2, 3. That's done. So now we just need our 2 square food stalls, which we know are going to be 2 centimeters squared. So let's do 1 down in this corner. Corners are good because it keeps them out of the way. So this is going to be a food stall. And we need another 2 by 2. So let's go in the opposite corner. We'll go over here. And that's our food stall. So we've got 2 square ones. So that's done. Okay, so I should have shown you I was drawing those down there. Now they don't have to be in those exact places. I could have moved them up, I could have moved these down a little bit, I could have had space around the outside if they'd fit. But think about making it easy to fit on, not necessarily the prettiest picture or the most practical. Just make life as easy for you as possible with the drawing. (11B). Tickets to the concert will cost £55. There is an early booking discount of 20%. Work out the total cost of 3 tickets using the early booking discount. So we can choose to take the discount off 1 ticket and then multiply it by 3, or we can multiply the cost by 3 and then take the discount off in one go. Really doesn't matter. I think I'll do it that way. So we'll do 3 times 55 with our calculator. So £165, that's without the discount. We want the discount, which is 20%, 20 out of 100, times 165. Which gives us £33. So if that's the discount, we need to take that off of the total cost, which gives us 132, so we can write that down here. Now we've got 11C. The concert will start at 7:30 p.m. Anya wants to know when to open the gates to let people in. She wants to allow at least 30 minutes to check tickets, and then 40 minutes for people to buy food and drinks. What is the latest time the gates should open? Well, let's start from 7:30 and we're going to work backwards. So we need to go back 30 minutes to check tickets. And I'm picking the 30 first because I can see that if I take the 30 off, take 30 from 30, we got 0. So that's going to take us back to 7 p.m. And then we want to go back a further 40 minutes. Okay, well, if you think in an hour, you've got 60 minutes. So if we do 60 minus 40, we're left with 20. So if we're taking 40 minutes off, it's going to take us 20. And of course the hour is going to go back 1, so it's going to be 6:20 p.m. Question 12. Holiday. Jack is planning a holiday to Turkey. 12A. He finds this information about average temperatures in Turkey. So we've got 1, 2, 3, 4, 5, 6 different months and the temperature in each of those months. On the grid below, draw a suitable diagram to show this information. Well, we've got a set amount for each month, so I'm going to draw a bar graph. So we're going to need, and I'm going to do a vertical bar graph as well, so my bar's going up. So we need 6 bars going up. So we want to make sure we can fit this in. Let's I'll start here. We could do 1, 2, 3, 4, 5, 6 and have it here, but that feels a bit squashed. Let's see if we've got space to do 2 of these for each month. So that'd be 1, 2, 3, 4, 5, 6. Yeah, that's going to fit in. Okay, so this is going to be our month, and it started from April, then we had May, June, July, August and September. Then we've got to think about the temperatures. Well, we want to know what the highest temperature is because we've got to make sure that our scale goes at least up to the highest one. So 28 is the biggest number. So again, we don't want to just go, we could say, well, 10, 20, 30. But, oh, didn't mean to do that. We've got quite a lot of space on the graph paper. So maybe, let's see if we've got enough room to do 4 of these boxes for each 10. So we could make that 10. 1, 2, 3, 4. Make that 20. And 1, 2, 3, 4. Make that 30. So I think that's going to fit. So we've got, so yeah, 4 squares between each. So that's going to be 0, and this is going to be temperature, and it's in degrees Celsius or centigrade. Okay, so now we can start to mark them out. Right, for the first month, April, we've got a temperature of 16 degrees. Right, well this is 10. Now, each of these little boxes isn't just going to be 1, because if you think, actually if we look at the bottom, from 0 to 10, we've got 5, 10, 15, 20 boxes. So 20 boxes for 10 degrees. Well, that means that each box, so we've got 20 boxes for 10 degrees. So if we do our 20 divided by 10, that means we've got 2 boxes for each degree. So I'm not going to write them all on, but I'll show you that would be like 1, 2, 3, and so on. Okay, so if we've got 16 degrees, well, this would be 10. 15 is going to be halfway, and then we want to go up an extra 2 degrees. So we're going to have a line there for 16 degrees. Okay. I'm just going to mark the tops of each of my bars. So for May, we've got 20 degrees. That's a nice straightforward one. We've got 20 degrees there. For June, we've got 25. Well, halfway between 20 and 30, that's going to be here. For July, we've got 28 degrees. So if this is 25, it's going to be 26, 27, 28. August, we've got 27 degrees, so we're just going to go down 2 boxes. And September, 24 degrees. Well, we know this is 25, so down 2, that's going to be 24. And now I can draw the vertical lines to make my bars. Okay, and I can just put a temperature, a title, and we can say Turkey temperatures. That'll be fine. Or we could say temperatures in Turkey, but that's okay. (12B). Jack decides to visit Turkey in July. The table shows the costs for a holiday in July. Okay, so we've got price per person for half board. So we've got 7 nights, 10 nights, or 14 nights. And the date of travel to Turkey. So this is how you decide the cost. If you're going between the 1st and the 10th of July, these are the costs. Between the 11th and the 18th. So the date that you're travelling out, these are the costs. And if you travel out on the 19th or anywhere up to the 31st of July, these are the costs. And there's an upgrade to all-inclusive for £21.50 per person per night. Jack wants to travel on the 12th of July and stay for 14 nights. He has £1,100 to pay for the holiday. Can he afford to upgrade to all-inclusive for all 14 nights? You must show you're working. So he wants to travel on the 12th of July. Excuse me. So the 12th of July is going to fit into this one. So we can forget about these and these. And he wants to stay for 14 nights. So that's the price we're interested in. Okay, so we've got the 760. We want to know about the all-inclusive. Now, upgrade to all-inclusive for £21.50 per person per night. Well, who's travelling? Well, it's just Jack. And he wants to stay for 14 nights. So £21.50 times 14. Oh, £21.50 times 14 gives us £301. So the total cost, if he went all inclusive, as well as the original price, is going to be 760 plus 301, which gives us £1,061. Well, that is less than 1,100, so yes, he can afford it. C. Jack will exchange some English pounds for Turkish lira. £1 equals 7.38 Turkish lira. Jack says, I want 6,500 Turkish lira to take on holiday. Work out the number of pounds Jack will need to exchange for Turkish lira. Right, I'm going to just draw a little table here. So we've got pounds, and we've got Turkish lira. Okay, and we know we've got £1 is 7.38 Turkish lira. He wants 6,500 Turkish lira. So if you think of this like with ratio or proportion, what we're trying to find out is how we would get from the 7.38 up to the 6,500. And the way we'd do that would be starting with the bigger number and divide it by the smaller. So 6,500 divided by 7.38. And that gives us 880.7588. Okay, so this is going to be the number of pounds because it's £1. So if we're going to be multiplying this by the same number, 880.7588, well, this number times 1 is going to stay the same. But because it's pounds, we want just 2 decimal places. So it's going to be 880.75. So we look at the number after the 5, it's an 8. So we're going to need to round that up to 76. But actually, they've said give your answer correct to the nearest pound. So not just the nearest pence. In fact, we're going to have to round that up to £881. Part D. The table shows information about flight delays for 60 flights to Turkey. So there were 36 flights with no delay, 13 flights with less than an hour delay, 8 flights with 1 hour to 3 hours delay, and 3 flights with more than 3 hours. Estimate the probability that Jack's flight will be delayed by at least 1 hour. Use the data in the table. Right, well, we want to know the total number of flights to start with. So we've got 36 plus 13 plus 8 plus 3. That's 60 flights. In fact, they told us it's 60, but no harm in working it out. So the denominator is going to be 60. We want the ones that delay by at least 1 hour. Well, at least is going to be this one and that one. And 8 plus 3 gives us a total of 11. So the probability is going to be 11 over 60, or 11/60. And that's it. End of the paper. So I hope you found it helpful. Please like the video, subscribe to the channel, turn your notifications on, and I look forward to seeing you again soon. Thank you. Goodbye.